Hello, is my voice clear?
Yes, sir.
In the last class, we have discussed about refraction of light. Okay, refraction of light means when light comes from one medium to another medium, they change their straight line path. This is called reflection. Refraction. Okay. There are two types of medium. One is rare medium. One is denser medium. Rare medium is means optical density or refractive index is low, and the speed of light is more. And denser medium means refractive index is high and the speed of light is less. Okay. Then the bending of light when it travels from one transparent medium to another is called refraction. So why it bending the why it bend? Because of a speed. Because of a speed. If someone asks the question, why light bend when it travels from one medium to another medium? Because of speed. Because light of speed in a different medium are different. Okay.
Okay, sir.
Then we learn laws of refraction. Here two laws are there: incident ray, normal, reflected ray. All are lie on same plane. It is like laws of reflection. Okay, but the second one is a little bit changes. The second one is called Snell's law. The ratio of a sine angle of incidence means the I is called as angle of incidence, sine angle to ratio to sine angle of a refraction. Angle R is called angle of a refraction. Sine angle is always constant. This is called Snell's law. Today we will learn this Snell's law. Details about this Snell's law. Then this is the phenomenon. Look, the light is coming from one medium. Then on boundary, it is after the boundary, it enter into second medium, and in second medium it changes the path. Okay. Some term related to refraction. Incident ray, the ray that strikes or falls on the surface. Point of incident, the exact point on the surface where the incident ray strikes. Reflected ray, normal, angle of incident, angle of reflection. These are the terms related with the refraction. Then in which condition, okay, we know this is the straight line of a light, but it is coming from one medium to another medium, so it will change their path. So two conditions are there. One is towards the when the refracted ray is changing the path, two conditions are there. It is towards the normal or outside the normal.
No.
When light is coming from one medium to another medium, it changes their path, but the question is it will change the path towards the normal or away from the normal. It depends upon the medium. If it is coming from denser to rarer, suppose denser is air, denser to rarer, denser. Okay. Denser to rarer means suppose light is coming from water and it goes to air. Here water is denser, air is rarer. That time away from the normal. Okay. When light comes from rarer to denser, like air to glass, suppose it comes towards it bend towards the normal. Okay.
Okay, sir.
Then we learn refraction through a glass slab. This is the light incident ray coming towards the surface. It is the point of incidence. Then it is coming from air to glass. So it two medium, air and glass. So air is a rarer medium and glass is a denser medium. That's why the refracted ray coming near to the normal, and the angle between incident ray and normal is called angle of incidence, and the angle between refracted ray and normal is called angle of refraction. Okay. Then look. Then after traveling through glass, because Suppose this is the thickness of a glass. Okay. After passing, it again coming to air. It again coming to air. Look, glass is a denser medium, air is a rare medium. That's why it goes away from the normal. Okay.
Huh.
When double refraction are happening here, double refraction na, refraction 1, refraction 2. In this case, this ray is called emergent ray. This ray is called emergent
Emergent.
ray. And the angle between normal and emergent ray is called angle of emergence. Angle of emergence. Okay. Then look, sir, what is this lateral displacement? Lateral displacement means suppose there is no any no change in medium. That means light should travel like this in straight line, na? The distance between emergent ray and incident ray. This is nothing but your incident ray, na? Is called lateral displacement. It's called lateral displacement.
Dispersion.
This is called lateral displacement. And after lateral displacement, we come to refractive index. Refractive index is nothing but the ratio between light comes from the medium, speed of a light comes from the medium upon speed of the
Light.
light goes to the medium. Always remember, the refractive index is nothing but the ratio between speed of light coming from the medium, because two medium is required, na? And speed of the light goes to the medium. But the important thing is refractive index is denoted by n. Look, generally in real life, light always comes from vacuum, because our source is sun.
Sun.
From sun, light is coming through the medium, vacuum or air. That's why sometimes we are finding n. N means refractive index equal to normal case. Speed of a light in vacuum. Speed of a light of vacuum is denoted by c upon speed of a light in a given medium. So the medium is glass. Okay.
Okay.
And it has no unit. And we know speed of light in air is 3 into 10 to the power 8 meter per second divided by v. This is the formula. Okay. Then come to two types of refractive index are there. One is absolute refractive index, one is a relative refractive index. Sir, what do you mean by absolute refractive index? If the first medium is, if the light is coming from air or vacuum, if light is coming from air or a vacuum, that time the refractive index is absolute refractive index. Otherwise you can say the first medium. This is generalized definition. If the light coming from air, okay, because the ratio is speed of a light coming from medium upon speed of a light going to the medium. This is the formula, na? So here, if the light is coming from air or a vacuum, that is called absolute refractive index. And second thing you have to remember, we don't find the refractive index of the light coming from the medium. We always find refractive index of the medium in which light is going. Okay. That's why here you look n of a glass. You can ask me, sir, why are you not writing n of a vacuum or air? Because we are finding absolute refractive index for the medium in which light is refracted. Okay. And the formula is C upon V glass. Okay. You understand absolute refractive index? Absolute refractive index means if the light is coming from, otherwise if the incident ray is coming from air, that time whenever we are finding refractive index, that is called absolute refractive index. In second case, look, relative refractive index. The fast medium is the fast medium, otherwise the light coming from the medium, the light coming from the medium
coming from the medium.
is other than air or vacuum. वो एयर और वैक्यूम नहीं होना चाहिए. Other than this, anything that comes under refractive index. Okay. Actually, here the meaning is, you have to remember, if n of a glass is written, that means refractive index of a glass, refractive index of a
Index.
glass. If there is nothing, that means you have to understand the fast medium is air. If here after comma there is nothing, that means you have to understand this belongs to absolute refractive index, or that means the fast medium is air. Okay. If it is right like this, remember n of kerosene means the second medium, because we are finding refractive index for second medium. This is the second medium, this is the second
Second.
medium. Otherwise you can say the refracted ray going through the medium. This is the meaning. If it this type of writing, suppose this is not, the meaning is refractive index of a kerosene with respect to water. What is the meaning here? Or refractive
Index.
index of a first one, kerosene, with respect to water. With respect to water. Number one thing, we always find refractive index for second medium. If only, suppose I am writing like this, n of a kerosene, nothing there, that means refractive index of a kerosene with respect to air. If I am mentioning, that means refractive index of a kerosene with respect to water. Okay. If nothing, that means it comes to absolute refractive index. If there is mention, that means it comes from relative refractive index. Okay. Have you any doubt here?
Got it.
Okay, I'm drawing one medium. Tell me. This is air. This is glass. By looking this, tell me, it is which type of a refractive index? Absolute to? Because look, the light is coming from air.
Yeah.
Okay. Another question, look. N of a diamond equal to C by V of a diamond. V of a diamond means speed of a diamond. If this formula is written, it is absolute or relative? If this formula is written, N of a diamond equal to C by V of a diamond, it is absolute refractive index or relative refractive index?
Absolute.
Absolute, because after comma there is nothing. Okay. Then come to this is the question we have did in the last class. The refractive index of a material is 1.4. If velocity of light in vacuum is this much, find velocity of light in a material. That means refractive index n is given. How much? 1.4. And velocity of light in vacuum, that means c is given. Find the velocity of light in material. That means it is which type of refractive index? Absolute or relative?
Absolute.
Absolute. So the formula become, that means this type of, this is the vacuum and this is any medium. This is any medium. So we always find refractive index per second, na? N of a material equal to C upon V of a material. V of a material is meaning is velocity of a light in material. This is we find, na? Then N of a material is how much? 1.4. equal to speed is 3 into 10 to the power 8 and velocity of a material we have to find. Then V of a material into 1.4 cross multiplied equal to 3 into 10 to the power 8. Then V of a material is equal to 3 into 10 to power 8 upon 1.4. Then V of a material equal to 3 into 10 to the power 8 equal to 1.4, convert it into fraction. Then 3 into 10 to the power 8 into 10 upon 14. Then 3 into 10 to the power 8, 10 divided by 14. 10 divided by 14. 0, 0, 10, decimal, 14 7 ja 98, 2, 0, 14 1 ja 14, then 6, 0, 14 4 ja 56. So it is approximately 0.714. This much meter per second. This is the velocity of a material. Okay. Now I think in the last class we have completed till this. Now look, this is the question. Okay. The refractive index of water is 1.50 and that of a glass is 1.80. Find the refractive index of water with respect to glass and refractive index of a glass with respect to water. Okay, my question is this comes under absolute or relative?
Relative.
Look, if only written the refractive index of water and here don't write with respect to someone, with respect to any medium. If in the question, if they only write refractive index of water and there is no mention of with respect to any medium, that means it is absolute. Means here n of water is given. Because it is absolute, meaning the first medium is always air, na? So n of water formula is C upon V of water.
C upon
V of water. Then n of a glass equal to glass equal to C upon V of water.
Yeah.
These two are given. We have to find the refractive index of a water with respect to glass. How to write it? It is relative. We know because with respect to is given. We have to find refractive index of water. That means second medium is water. With respect to glass. That means first medium is glass.
Glass, sorry.
Then refractive index of a glass. That means first medium is second medium is glass. With respect to water. That means in this question, two absolute value are given. Two absolute refractive index is given. We have to find two relative refractive index.
Yeah.
Look, n of water is given. N of water equal to C of water, C upon V of water equal to 1.50. It given, na?
Yes, sir.
Then n of a glass equal to C upon V of water is given. These two things are given. We have to find n of water with respect to glass, n of a glass with respect to water. Then how to find? Okay, tell me. N of water with respect to glass formula should be like the which type? Tell me. N of water with respect to glass.
Water.
It is relative, that's why comma glass. Then the formula?
V by V. V1.
V, first V of water. The medium in which you are finding the refractive index, you have to write in denominator and the first medium should be in a, look here, na? C is the first medium. Here glass is the first medium. How we know glass is the first medium? Because it is telling na refractive index of water with respect to glass. That means water is the first medium. The second medium. Glass is the first medium. That's why the formula become V of a glass upon V of a water. In second case, the formula N of a glass comma water. Formula.
Yes, sir.
Tell me the formula. In second case.
We we
Hmm. Second medium. V of a first medium. In glass. A.
water.
V of a water upon V of a glass. Upon V of a glass. This is the two formula and this is the given things. This is the given things. Okay, just wait. I am opening one new page. You understand what are the given things?
Yes, sir.
Look, these are the given thing. We have to find the. Okay. The question is asking me us to find N of a water with respect to means refractive index of a water with respect to glass and refractive index of a glass with respect to water. This is given. Okay. Look this formula. From this formula, can I find velocity of a water? From this formula, can I able to find velocity of a water? Means speed of light in water. From this formula, can I find a velocity of a glass? Sorry, light of a speed of a light in a glass. This is glass.
Yes, sir.
Okay. If I find and after finding this, I can easily find refractive index of water with respect to glass and refractive index of a glass with respect to water. Na? I can easily find. Then from this, find velocity. Okay. How it becomes? Equal to what is the C value? 3 into 10 to the power 8 na?
Yeah.
Upon V of water velocity, the speed of light in water we have to find.
Fine.
Equal to 1.50. Equal to 1.50. Equal to multiply, cross multiply. Speed of light in water into 1.50 equal to 3 into 10 to the power 8. Okay?
Okay, sir.
Then velocity of light in speed of light in water equal to 3 into 10 to the power 8 upon 1.50. After decimal, no need to write 0. Okay? Equal to, simplify it. 3 into 10 to the power 8 into 10 upon 15. 10 upon 15. 3, 5. 5, 2. Equal to 2 into 10 to the power 8. This is nothing but your speed of a light in water. Okay? And you are finding speed, so meter per second. Okay, from the first formula, we find speed of a light in water, that is speed of a light in water, that is 2 into 10 to the power 8 meter per second. Okay? Then come to second formula to find the speed of a light in a glass. This type of question you have to prepare. At least one question will come in your final exam. So speed of a glass, light in a glass equal to 1.0. And you know V of a glass is equal to, if I put the value 3 into 10 to the power 8 upon 1.8.
Yeah.
Then 3 into 10 to the power 8 into 10 upon 18.
Yes, sir.
10 upon 18. If you cut, it become 6. So if you finalize the answer, you will get 1.66 into 10 to the power 8 meter per second. This is nothing but speed of a light in glass. Now you find two things: speed of a light in water and speed of a light in glass. Now we can easily find this one. Means refractive index of water with respect to glass. The formula is V of glass, means speed of light in glass. How much? 1.66 into 10 to the power 8 upon 2 into 10 to the power 8. Okay, because speed of light in glass is this much, na? And speed of light in water is this much. So 10 to the power 8, 10 to the power 8 cancel. Now it remaining 1.66 upon 2. If you simplify this, you will get refractive index of water with respect to glass. If you simplify this, means remove the decimal point, it become 166 divided by 200. Because multiply by 100, na? And it become 0.83. And you are finding refractive index, that's why we don't require unit. Then if you find this one, means refractive index of a glass with respect to water, V of water, speed of light in water, 2 into 10 to the power 8, 2 into 10 to the power 8 upon 1.66 into 10 to the power 8. This and this cancel. You have to simplify 2 upon 1.66. Okay, it will become 200 upon 166. If you simplify this, you will get 1.2. Okay? Now you understand? Okay, this is the 2025 question. You have to prepare. With this, we completed the refractive index concept. Then comes to Snell's law. When we are learning about laws of refraction, there one thing we came, that is the ratio of a sine of angle of incidence to sine of angle of refraction is always constant. This is the Snell's law, or we can say this is the laws of refraction. But the remaining part is for a given pair of media, that is when the media do not change. Okay, I understand sine of I and sine of R always be constant, but there should be two conditions. There should be two conditions. The condition is pair of media should be changed. So should be same. If you change the media, then this value do not be constant. Okay. And the second one is for a given wavelength or color of light. That means if someone asks you the question, sine of I and sine of R become constant until you don't change the media or you don't change the wavelength of a light. Okay. If you don't change, then always this become constant. If you change, then you will get different answer. Okay. That means this is the Snell's law. You have to remember by heart the Snell's law. The ratio of a sine angle of I to the sine angle of R remains constant until, but for a given pair of media. Media is nothing but plural form of a medium. Okay. And for a given wavelength. Then look this diagram. Suppose in the first diagram I am taking first medium as air, second medium as a glass, air, water, air, diamond. Are you thinking in all these cases sine I upon sine R you are getting constant? Are you understand my question? My question is in these three diagram I am changing the media, na? In first diagram air, glass, second medium air, water, third medium air, third diagram air, diamond. If I change the media, then 100% in every case I will get the different constant value. Okay. That means here sine I upon sine R become different for these three diagram. Okay. If all these case I remain different constant the media, that means in all these three cases sine I upon sine R becomes equal. Okay. Two things means sine I upon sine R become constant depends upon two things. Pair of media, if the pair of media is same, then no change. If pair of media is changing, then changing. Then the second one is wavelength. What do you mean by wavelength? Look, wavelength means you have to change the color of light. Look, in the first media, in the first diagram, I'm taking a red light. Look, wavelength changing means color of the light changing. Okay, you are looking different types of color because of a wavelength. Okay,
Hmm.
in first diagram, I'm taking a red color light. In second, green color. In third, blue color. Then here the sin I upon sin r, suppose equal to constant, suppose x 3 here you never get 3 except 3 here some on. Why? Because we change the color of light. Okay,
Hmm. Okay, sir.
that means sin I upon sin r becomes constant for a pair of a media wavelength is same. If same, then you will get sin I upon sin r constant, or otherwise different. Okay, you understand about Snell's law?
Okay, sir. Ah.
Then come to spherical lenses. Spherical lenses. Look, always remember reflection. In reflection chapter, you will learn about mirror. In refraction chapter, you will learn about lenses. I mean, this is the use of a reflection. This is the use of a refraction in daily life. Okay. In reflection, we learn two types of mirror. One is concave, one is convex. Concave means the reflecting surface is a cave-like structure. Convex means enlarged-like structure. Okay.
Hmm.
Here you look. Convex. Spherical lenses. Convex two types. Convex lens, concave lens. Convex means thicker at the center, thinner at the edges. In convex, look, in center they have thicker, and in a
Ah.
thinner at edges. Look, this is called the center. In center, these lenses are thicker. In edges, this is called edges. This is called the center,
Ah.
and this is called edges. In edges, this is thinner. Okay, the spherical lenses in which the center is thicker and the edges are thinner are called convex lens. Okay, and the spherical mirror in which center is thinner and edges are thicker,
Thicker.
are called the concave lens. Okay, a lens is a portion of a transparent optical material that has one or two spherical surface. Look, here how many spherical surface? Look, for this circle, this is looking like a part of circle. This is also looking like a part of a circle.
Circle.
Means a lens is looks like part of a two spherical sphere. Look here also. Okay.
Ah.
Types of lenses. Convex lens is thicker at the center and thinner at the edges. You have to remember the definition. Then come to lens. Look, some terms are related with the lens. Suppose this is nothing but a circle, sphere. This is also a sphere. The center of this circle is called 2f. Is called 2f. Here we are not calling center of a curvature. Here we are calling 2f. Okay,
Ah. Okay, sir.
and this is called the optical center. Look, the center of the lenses is called the optical center.
Hmm.
Okay, and this side 2f, 2f. This is 2f, 2f. The center of the lenses is called the optical center, and the center of the two spheres are called 2f, 2f. Then the distance between, then the midpoint between 2f and 2f and O is called the f. Focus. You know na?
Ah.
F, f. So it is repeating. That's why the left hand side is taken as 2f1, f1, f2, 2f2. Okay.
Okay, sir.
First thing, the center of the lens is called, look, the term, some terms related with this optical center, the center of the lens. Suppose this is a lens, the center of the lens is called optical center. Principal axis, a line passes through a line passes through optical center is called the principal axis. Focus point where refractor rays are meet or appears to meet. We will learn this. Just wait. Focal length, the distance between focus and optical center. Then look this diagram. O optical center. Optical center means the center of the lenses. Okay. Focus. The point at which refractor rays are appears to meet or meet. We will learn this. 2f twice of focus means these to this to this is called focal length. You know about focal length, na? The distance between focus to optical center. The radius of curvature, you know, r is the radius of curvature, the distance between center of the sphere to the surface. Okay.
Okay, sir.
Have you any doubt here?
No. Got it.
Okay. Then look here, I am doing again. This is the optical center. This is 2f, 2f, 1. That is focus 1. This is focus 2. 2f1, f1, f2, 2f, 2, f2, 2f. Okay. Just a minute. Are you understanding? Okay. Then look here. Read the focus definition. Point where refracted rays meet just
Hello, sir.
yeah, or appears to meet. What does it means? Look, suppose in convex lens, one light coming parallel to principal axis. Always you have to touch this line. Okay. So it is refracted and meet at a f1. Okay. In convex lens, if a parallel line, look this diagram. Look. A parallel line is coming parallel light after reflection. After refraction, they meet the right hand side f2. Here two focus are there, na? One is in left hand side, another one is right hand side. So in convex lens, if two parallel lines are coming, if two lines parallel to principal axis coming, after incident, the refracted ray are meeting with each other in f2. But if you look convex lens, concave, look, two parallel light are coming, but they are diverging. Here look, it appears to meet at a f. Okay. You understand what happening in convex lens and what happening in concave lens. In convex lens, refracted rays are gathering point f2, focus f2, but here lights are diverging. That's why convex lens is called converging light. Converging means you have to gather the light. Here you look, na, in f2 we are gathering the light, na? But diverging means, look, you have to diverge means you have to send in different direction. Here We are gathering, here we are differentiating. So look, concave mirror is called the converging, but convex lens is called converging. Okay,
Hmm.
are you looking the difference? In case of a mirror, concave mirror is converging, but in case of a lens, convex. And in case of a mirror, convex is diverging, but here concave is diverging. Okay,
Diverging. Okay,
parallel
sir.
lens covers converge at the focus after refraction. After refraction, converge means they gather. Parallel lens diverge after refraction, they appear to come from the focus. Look, after diverging, we make this line.
Hmm. Yes, sir.
Okay, based on this, we have to learn the rule. You remember the rule of a concave mirror from for
Okay.
image creation? Suppose this is a concave mirror. If the light that coming parallel to principal axis, they will meet at
This is
focus. At
at
focus.
focus.
Or if the light is coming through the focus, they go parallel to principal axis. If the light coming through the center of a curvature, then it return back. Then it return back. If a light is coming through the pole, the angle of incident is equal to angle of a refraction. These are the four rule we have already learned in concave mirror. But here we have to learn. Look, number one rule. Look, three rules are there. How many rules are there?
Three
Three.
rules.
A ray parallel to the principal axis. Look, rule number one. A ray parallel to principal axis. Always you have to touch the incident ray to this dotted line. Okay.
Hmm.
Passes through the focus F2 after reflection. If the ray coming parallel to the principal axis, it passes through the focus. We have two focus, but you have to remember right hand side focus. Okay.
Ah, okay,
Second
sir.
case, a ray passing through the focus. Suppose a ray is passing through the
Focus.
focus. Emergence parallel to the principal axis. This is wrong. Okay. They go like this. Parallel to principal axis. Okay. This is wrong. This is wrong. Don't look this. Okay. First thing, if a ray coming parallel to principal axis, they passes through the focus. This is rule number one. If a ray
One.
coming through the focus, okay, focus M1
Yeah.
emerges parallel to principal axis. Emerges parallel to principal axis. This is rule number two. A ray passing through the optical center. Look, a ray passing through the optical
Center.
center goes on deviated, means coming from the direction to return back to same direction. You understand or not?
Understand.
Okay, because these things we require for making the ray diagram. Here also 8 cases, but here convex having 6 cases, concave having 2 cases. Rules for obtaining image from a concave lens. We completed for convex lens. Concave lens. A ray coming parallel to the principal axis diverge. Look, after refraction it diverge, but appears to meet through the focus on the same side. Look, on the same side it appears to meet.
Meet.
Ray parallel to principal axis appears to pass through focus F1. Actually, really it diverge, but appears like meets at F1. Okay, on the same side. This is
Ah.
the side number one. This is the side number two. In convex lens, it meets at F2 of a different side, but here same side. Ray passing through the optical center goes on deviated. Look, rule number two. Rule number two. Here it is wrong. Ray passing through the optical
Optical.
optical center remains on deviated, means no change. And ray directed towards focus F2. Look, this is the ray directed towards F2. Emerges parallel to the principal axis after refraction. Okay,
Okay.
you understand these three?
Ah.
Look, this is wrong. This is wrong. Rule number 2 is if a ray coming through the optical center, it remains undivided. This is rule number 2. If you have the confidence, then we will go for ray diagram. You understand?
Okay, sir.
Okay. Okay, tell me in concave lens 3 rules. Tell me. Rule number 1. In convex lens, rule number 1. If line coming parallel to principal axis,
Principal axis.
it meets at F2. It meets at
Yes.
F2. If light coming from F1 remains parallel to principal axis. If light passes through optical center, it remains undeviated.
On tent.
Undeviated. This is for convex. Concave.
Okay.
If light coming parallel to principal axis, then it appears to meet at F1.
F1.
Concave. If light passes through optical center, remains undeviated. If light coming
Huh.
coming towards the F2
F2.
becomes parallel to principal axis. These are the
Hmm.
6 rule. Come to
Hmm.
convex lens image formation. Convex lens image formation. Okay. You remember the 6. Here we will learn for convex 6, for concave 2. Total 8 case.
Yes.
Try to help me. Object at infinity. Suppose object at infinity. Okay.
Huh.
When object at
Okay.
infinity, always you remember you have to take two light from parallel. When object at infinity, to make the ray diagram, always take two light coming from parallel to principal axis. Okay.
Huh.
Then tell me, in convex lens, if lines coming parallel to principal axis, they will meet in which point? This is 2f1, sorry, 2f2,
F1. F2.
2f1, f1, f2. This is O. Tell me, if light coming parallel to principal axis in convex lens, where they meet?
Huh.
Where they meet?
F2.
F2. F2. Then look, tell me the nature of image. Image formation at F2.
F2.
Size?
Real and inward.
Size highly diminished. Highly
Highly diminished. Diminished.
diminished. And you look, they are meeting. They are meeting. So nature, real and inverted. Real and
Inward.
inverted. Okay, you understand?
Huh. Yeah.
Okay, then object beyond 2f1. Suppose object beyond 2f1. This is 2f1, f1, 2, sorry, f2, 2f2. Okay, this time one ray you have to take parallel to the principal axis, and,
Okay.
and another through focus, another through focus, f1. Okay, tell me, if a line coming parallel to principal axis, then they will meet. But after reflected, the refracted ray passes through the f2, na?
Yeah.
And if the parallel light, if a light coming through the focus,
It stays
parallel to principal axis, parallel to
parallel to
principal axis.
principal.
Here image is forming. Here image is forming. Okay, nature of the image. First, tell me where the image is forming.
At
Between f2,
between
f2 and 2f2.
yes.
Then size. Look, this size diminished.
Diminished.
And nature.
Real and inverted.
Real and inverted. You understand?
Yeah.
Look. Object at infinity, this is the ray diagram. Look. At F2, highly diminished, real inverted. At the between F2 and 2F2, diminished, real inverted. Okay. Then took the third condition. Object now this is 2 F1, F1, F2, 2F2. This time we have to put object as a at a 2F1. Same one line parallel, one through a focus. Just a minute. Okay. Look, when object at 2F1, you have to take one line parallel, one line through the F1. Tell me nature of the image. Where the image is forming? At 2F2. At 2F2. Size same. Size same. And nature real and inverted. Real and inverted. Understand this condition?
Yes, sir.
Object is between 2F1 and F1. This is 2F1, F1, 2, sorry, F2, 2F2. Object is here. Same, one line and another through focus. Through focus. Sorry, just wait. This is important. Okay, you have to practice.
Okay.
Okay. Look this diagram. It's difficult to look. Look. This we have already completed this one. Look, when object is between 2F and F1, look beyond F2 F2. Image is forming beyond 2F2. Look the size enlarged. Look the size enlarged. Real inverted. But this time look. One interesting thing is there. Look. In exam you have to remember na. Look. If infinity 2 ray took from a parallel. If beyond 2F1, one parallel, one through focus, one through focus.
Okay.
If object has 2F1, one parallel, one through focus, F1. But here, when the object is between these, you have to remember one should be parallel, one should be parallel. But second one is through the optical center. And you know when the object is coming through optical center, a line it is undeviated. Okay. Now look. Image is created beyond 2F2, enlarged, real, inverted. Okay. Then come to object is at F1. In fifth case F1. So one ray parallel. Okay. Second one through optical center. Look, then tell me nature of image. Image will create at where? Infinity. Where? Infinity. Then image is size, image size. If infinity 100% remember enlarged. Okay. And real and inverted. You understand? This is 2F1, F1, F2 to F2. They will never meet. They will meet at infinity. Okay. Sixth one, important, most important. This one, most important. Look, object is between F1 and F2. So F1 and O. Same. One parallel, one through optical center.
हाँ
If parallel, then through focus, then look.
focus
They are diverging. They are diverging. This is F2 to F2, F1 to F1. This one is the important. Look, they will never meet each other. They will never meet each other. They are diverging. Suppose, look, when they will not meet, they appears to meet. They appears to meet. Where? Behind the lens. Behind the lens. Okay. And look the image size. Look the image size. It is enlarged. It is enlarged.
yeah
And appears to meet. So virtual. Appears to meet means virtual. And virtual means erect. Okay. You have to remember this condition. You have to remember this last condition. In every cases, real image, then inverted, but this is the case. With this we completed image formation in convex. Look, you understand? Hello.
okay sir.
Then come to image formation by concave lens.
Yes sir.
In image formation by concave lens, two conditions are there. Object at infinity, object at a finite distance. This is distance 2. Suppose object is infinite. Take two parallel line. Always you remember, if infinite distance, then we have to take parallel line. And you know, if the line coming parallel to principal axis, they will diverge. They will diverge. And if they appears to meet at a F1. Okay. Now tell me, nature of the image. Where the image is forming? At F1. At F1.
One
Size dotted, diminished, highly diminished.
dotted
Dotted means highly diminished. And nature appears to meet. That's a virtual and erect. Virtual and erect.
erect
Then come to object at a finite distance. Finite distance mean not beyond the 2f1. Here, suppose here, one coming parallel, another through f1. Okay. This one through the focus. Just a minute. Second case. Okay, sorry. Second case. Not through this. You have to take through optical center. Oh, sorry. Why I'm doing this? That's why I'm getting wrong. Look, one parallel to principal axis, so they will deviated, na? Second one,
yeah
second one through optical center, through optical
optical
center. And you know, optical center remain undivided, and this diverge. It appears to meet at a f1. Okay. Here you look.
okay sir.
The object is forming between f1 and o, f1 and o. Then a diminished,
Oh
diminished, and virtual and erect, virtual and erect. Look, practice, otherwise you have to practice 10 to 15 times. Look, this is the entire condition and this is the diagram. You have to remember this one. Then come to sign convention and formula. Look, in any cases, you know object distance is always positive, negative. It is same like sign convention is same like mirror. Look, object distance means the distance between object, the distance between object and the optical center is called image distance. Look, u and u is always, look, whether it is convex or concave, it is always residing in the left hand side, na? So u is negative.
Yeah.
U is negative. V is the image. V depends upon V we will find. V we will find.
Fine.
Okay, look, focal length. Focal length, the distance between F1 to O, the distance between O to F2. Okay, by looking this, tell me, focal length is important for in convex lens. Focal length always consider this one, na? Because left hand side we don't require, na? So right hand side means positive. Focal length is positive in convex and negative in concave. Okay. Radius of curvature. Radius of curvature same. Positive for a convex and negative for a concave. Okay.
Okay,
And HA object height you know always positive, and image height we will find.
fine.
Look what we find. U always negative. HO always positive. After this image we will find find focal length for concave, convex always positive, but for convex always negative. Concave always negative, convex always positive. Remember or not?
Yes.
Then come to same formula. Look, mirror formula is 1 by f equal to 1 by v plus 1 by u. Here only minus, here only minus. And magnification, in mirror magnification equal to minus v upon u, but here only v upon u. And you know the second formula, m equal to hi upon ho, and the one you know, if magnification is less than 1, that means diminished, image is diminished. If equal to 1, same size. If greater than 1, enlarged. And you know m is positive for virtual and erect, m is negative for real and inverted. Are you clear or not? Clear? Okay. Then come to one problem. Look the problem. A convex lens. Which type of lens? Convex lens. Produces real and inverted image. You know. Remember the cases. Real and inverted. Image 2.5 times magnified at a distance of 25 centimeter. The image. Calculate focal length. Okay, tell me what are the given things. By looking this, tell me what are the given things. Read the question.
It is real and inverted. Like
first, tell me what are the given things. M is given. Magnified means M is given. 2.5. Okay, 2.5 is positive or negative? Tell me.
It is positive.
Real and inverted positive.
Sorry, negative.
Then look, a convex lens produces a real and inverted image 2.5 times magnified at a distance of 25. At a distance, that means image distance equal to 25. Sir, is it positive or negative? Image distance is positive and negative. Think. Positive or negative? Okay. Look, remember the conditions. object becomes real and inverted. Object becomes real and
Inverted.
inverted. Object distance 25. Sorry, image distance. Image distance 25. Okay, tell me. Except six condition. Except six condition. 6 number condition. Always the image is forming left hand side or right hand side. Look. Look. In first condition, image is forming right hand side. Here also right hand side. Okay. Look. In every cases, object is forming in the right hand side. Right hand side. Only one cases, that is 6 number case. But in 6 number case, we will get virtual and direct image, na?
Yeah.
But here question is giving you real and inverted. That means it is not comes under 5th number case, na? The 6th number case, na? That means m equal to minus 2.5, v equal to 25, v equal to 25. Then from we have to find f, focal length. We have to find focal length, and you know the length formula, 1 by f equal to 1 by v minus 1 by u.
Yeah.
V is given, we have to find u, na? Then okay, how to find u? We have to put the magnification formula, m equal to v upon u. For convex it should be positive, for lens it should be positive. So m is how much? Minus 2.5 equal to v is how much? 25. V is how much? 25. U we have to find. U we have to find. So u equal to 25 upon 2.5. 25 upon 2.5 minus equal to 25 upon 10. 25 into 10 upon 25. Are you looking? Minus, always minus, because minus there. 25 cancel. U equal to minus 10. Look, you know na, always u minus in any cases. Okay, now we find u. Are you looking? Then put in mirror formula. Put in lens formula. 1 by f equal to 1 by v. V is how much? 25. Minus u is how much? Minus of 1 upon 10. Okay. Then 1 upon 25 minus plus 1 upon 10. This become 50. 25 and 10 LCM is 50. 52 plus 5. 1 upon f equal to 7 upon 50. 7 upon 50. So 7f equal to 50. F equal to 50 upon 7. 50 upon 7. Look, positive is coming. If you remember in convex lens, f should be positive. F should be positive. Here you look. F equal to 7.77 centimeter. You understand or not?
Understand.
Okay. Look, from real and inverted, I know m value. I am using the open formula 2.5. That is minus. And I know if real and inverted, image always created in right hand side. That's why I took the object distance or image distance as positive. Then I find the u. Then applying the lens formula, I am finding the f. Have you any doubt or not?
Understand.
Look this question. An object is placed at a distance of 10 centimeter. That means u is given minus 10. U is given minus 10. Because you know always u is negative, na? Convex lens. In convex lens, focal length is positive or negative? Positive. That is 15. Find position and nature of the image formed. Tell me how to find.
Mm,
Position means image distance. Image
image distance.
distance, that is V, and nature of the image means real, or because in convex lens also, real and erect, sorry, inverted and virtual and erect image is creating, na?
Yeah.
Okay. First, I am finding V and M is asking. Okay, from mirror formula, sorry, from lens formula, can I find V? Because V is required, na?
Ah.
Okay, lens formula is 1 by F equal to 1 by V minus 1 by U.
Yes, sir.
1 by F. F value is how much? 15.
15.
Equal to 1 by V minus of a minus 1 upon 10. Then 1 by V minus minus plus 1 by 10 equal to 1 upon 15.
Yes, sir.
Then 1 by V equal to 1 upon 15 minus 1 upon 10.
Ah.
10 and 15 LCM is 30.
Yes, sir.
Then 2 minus 1. 30 divided by 15. 2 minus 3. 2 minus 3.
3.
Okay, look, I'm doing here. Then 1 by V equal to minus 1 upon 30. Then V equal to minus 30 minus V equal to 30. V equal to minus 30.
Ah.
You can ask me, sir, in convex lens I am getting V equal to minus 30 means 100% is the 6 condition. Okay. Okay, then you have to find M. Then you have to find M. Okay, M formula is V upon U. V upon U. Okay.
Ah.
Then V is how much? Minus 30. U is how much? Minus 10. 3. Then tell me, which type of image is create? Size. M is greater than 3. Size is enlarged. Size is
Enlarge.
and
Enlarge.
M is positive. That means virtual and erect. Virtual and
Erect.
erect. By looking the image distance also you can understand. Minus means 6 condition. 6 condition means virtual and erect. Okay.
Okay, sir. Ah.
Then power of the lenses. Okay, what do you mean by power of the lenses? The ability to the ability of a lens to converge or diverge rays. Okay, just now only remember, when I will show you the diagram you will understand. Okay, the ability of a lens to convert.
Ah.
We know in convex lens the refracted rays are converging. In concave they are diverging. How much diverge means how much diverge. Okay, in how much angle they will diverge to each other is called the power of the lens. And the formula is P equal to 1 upon F. 1 upon F meter or 1 upon 100 upon F centimeter. Okay.
Ah.
Then it is measured by diopter. Diopter. Its unit is diopter. Then for converging lens means converging means convex. Converging means convex. Power is always positive. Power is always positive. Are you understand or not?
Yes, sir.
Number one thing, power of the lens means ability of a lens to converge or diverge rays. Okay. Its formula is P equal to 1 upon F. Unit is diopter. For converging means convex lens, diopter is positive. For concave lens is negative.
Ah.
Look, that comes to here. Suppose, what do you mean by power of a lens? Try to understand. Look, this is such a thinner convex lens. Means it is thin. It is thick, na? Are looking the difference between these two? Two are convex. Two are convex. But it is thinner. It is thicker. Are you looking?
Yes, sir.
Okay. Suppose I am, and if it is thinner, That means this circle is larger, na?
Yeah.
This is this like circle, na? Sphere, na? And
Hmm.
if thinner, that means its center means 2f2 is a little bit far. 2f2 is a little bit far. If you compare to this, means this is such a small sphere. Means these lengths are part of a small sphere.
Yes.
Okay. Then this means here 2f2 is here, little bit closer to the optical center.
Ah.
Okay. Then this is f2. This is f2. Suppose many parallel lines are coming, parallel rays are coming, and you know if parallel rays coming, if light coming parallel to principal axis, they will meet at f2.
Yes, sir.
Okay. Here also same. Here also same.
Same.
Look, it is a thinner. This angle and you look this angle is greater, na? This is called the
Ah.
power of the lens, na? The power to
Yeah.
converging or diverging the light. Here you look, they are converging the angle between. This is the normal light path, na? The lens is converging. Suppose this is 30, this is 50.
Ah.
Are you looking? That means thinner lens, thinner power, thicker lens, thicker power, higher power. Okay. Now you understand what you mean by power?
Ah.
Suppose a light is going. Suppose here lens is not there. Its path should be straight, na? It is.
Yeah.
It is thinner lens. That means look the angle here and here. The converging or diverging. Here diverging. Here sorry converging. In
Hmm.
lens number one, look the diverging angle. The diverging angle means the line, the angle between straight line of the light to the to the converging angle, to the converging. Okay, this is power. Two question, two question are there based on power. Look, a eye specialist prescribed a number of 4.5D. D is nothing but diopter. Okay. Oh, this question is wrong. Look. An eye specialist prescribed a number of 4.5D to a person for his glasses. What is the nature of the lens? Nature of the lens means? And what is the focal length of the lens? Nature means it is converging or diverging. Plus means? Tell me.
Ah.
If power is plus, that means which type of lens it is? Converging or diverging? Means convex.
Convert.
Converge means it is convex. It is convex. But you have to find the focal length. You have to find the focal length. Okay. P is given 4.5.
Ah.
We have to find F. F equal to question mark. What is the formula? P equal to 1 by F. P equal to 1 by F. Then
Yes.
4.5 equal to 1 upon F. 1 upon F.
Ah.
Then 4.5 F equal to 1. F equal to
Yeah.
1 by 4.5 equal to, remove the decimal, 10 by 45. Okay. If you simplify 10 by 45, if you simplify 10 by 45, you will get 0.22 meter. This is the focal length. Are you understand or not?
Yes, sir.
Last question of this chapter. Two thin lenses of power, this and this, are placed in contact. Calculate of their combination and focal length of their combination. What does it mean? Look, it is convex, it is concave, means two lenses are there, they are attached to each other, they are attached to, hello,
sir.
two lenses are there, hello, they are attached to each other. First lens number 1 is a convex lens. Lens number 2
हाँ
is a concave lens. Okay, so
okay sir.
P1 equal to plus 2.5D, diopter is the unit of power, and P2 is equal to minus 1.5D. Calculate power of their combination in total. P1 plus P2,
हाँ
P1 plus P2 equal to 2.5 plus 1 minus 1.5, 2.5 plus minus 1.5, it will be 1.1 1D.
yeah
This is the total combination, plus 1D. Now we have to find the focal length. Okay, P equal to 1 upon F. P value is how much? 1. 1 equal to 1 upon F. F equal to 1 meter. Okay, you understand this chapter?